All right, today we're going to be working on page 15. And we're not going to hand these assignments in by the section they're in. So in your notebook, I want you to just write page 15, 1 through 38 odd. That's how we'll put them in your grade book. So page 15 is chapter 0, which means it's not new material. It's just review stuff. But a lot of what we do today is actually going to be review because you guys have seen most of this stuff already. Okay, solve for the indicated variable. If I had a marker, 3x plus 4 equals 13. Wait. Yeah, that's right. How do we solve this? We subtract 4. Why do we subtract 4 and not divide by 3? Yeah, to get the variable by itself. But why the 4 and not the 3? The 4 is connected to the variable 2. What? Well, there is a much harder way to do it. But nobody's really taught you this before. How do I know I do the 4 first? Because my teacher told me. Yeah, what did they say? Well, you got to get the variable by itself. But this variable is connected to both numbers. It's connected to the 3 through multiplication, and it's connected to the 4 through addition. So why addition? Why do I get rid of the addition first? What's that? Okay, not as close. What do you mean? You're right. And what rules do we use for closeness? We don't call it closeness. We call it... nope, it's not the associative property. Okay. It has to do with order of operations. Now, when I moved into this classroom, that order of operations sign was up there, and I'm too short to take it down. And it's correct. You know, the whole please excuse my dear Aunt Sally. But it's a little bit misleading because it says that multiplication is higher than division and addition is higher than subtraction. Is that really true? No. Multiplication and division are the same. We just do them left to right. And addition and subtraction are the same. So I prefer, I'm pushing buttons with my back. I prefer this. So this is parentheses, exponents, and this one is division and multiplication because they're really equal. They're really the same thing. And then addition and subtraction, and we perform them left to right. Okay? So, why is the 3 closer to the x than the 4? It's higher up on the pedal, right? If we look at that expression, 3x plus 4, which one hits x first? The 3 does, because multiplication is higher on the list than addition. Okay? So, if I'm seeking to isolate the x, I have to, equations are like ogres. You guys might be too young for this one. They have layers, right? So if we want to get to the center of this onion, we've got to peel the layers off one at a time. Well, can you remove an inner layer of an onion from the start? No. Well, you can. It would just be very, very difficult, like Carly said. There is a way to move the 3, but it's really complicated, so we don't do it. So, here's what we do. I love this. we're going to pedal backwards. So, focus on the x. What's the first thing that happens to the x? The multiplication. That's step 1. What's the second thing that happens to the x? This operation, plus 4. So if I want to determine what x is, I have to reach it by starting with the outer layers and working backwards until I get to the inner layer. Does that make sense? Now, for a simple equation like this, your teachers just said, oh, the 3, you have to get rid of the 4 to get the x by itself. They didn't really teach you the process behind it. And now all I do is reverse each operation. So subtract 4, and I get 3x equals 9, divide by 3, and we get x equals 3. And then it's always a good idea to plug it back in and see if it works. So if I stick this in here, I should see those exact same steps in reverse order. 3 times 3 is 9, and 9 plus 4 is 13. That make sense? Okay, I believe there's a new button where I can just do that. Awesome. So, what if I had I don't know if this is going to be a nice number or not. Nope, it's not. Okay. So, look at the x. What is the first thing that happens to the x? Multiplied by 2. What's the next thing that happens? Subtract 5. But isn't multiplication higher on the list than subtraction? It's inside the parentheses. So we have to finish the parentheses before we can move to the outside. So this is step 2. This would be step 3, and this would be step 4. Now I just work backwards. I undo every layer using the inverse operation. So plus 7 equals 24. Divide by 4 equals 6. Add 5 equals 11. Divide by 2, and I get 11 halves. Does it all of a sudden make sense to you? Okay. So let's look at something like 7x plus 4 equals 20 minus 5x. This one's a little bit different because we have 2 x's. What should I do? Put all the x's on one side. Do we have a preference? Why add 5? We don't want a negative x. Does it really matter? No. It's not going to change our answer. It's easier to avoid mistakes if you keep your variables positive. So we add 5x, and I get 12x. Now what? I might as well move that 4 to the other side. So what is that? Take a 4 out. 4/3. Does that make sense? Okay. What if, let's see. This is a new function. Maybe my board doesn't do it. Let's do this. And I got to get out of that. Sorry. All right, let's look at number 22. What are we going to do there? Well, on this side, I think I can use a marker. On this side, I need to simplify down as far as I can. And then on this side, I need to simplify down as far as I can, and then I can start looking at operations. So I need to distribute this 3. And I recommend that you write everything out, because it's really easy to make a mistake. So 25 minus 2 plus 5y minus 3y minus 6. Okay. And then that turns into 25 minus, those become 2y, and those become negative 4. Now what? What should I do next? I need to distribute this negative. What does that accomplish? Just changes the signs. So 25 minus 2y plus 4 equals. So over here, I'm going to distribute the negative 3. So negative 6y plus 15. And then I'm going to distribute the 5. So minus 5y minus 5 minus 3y plus 3. And there's really no difference between a bracket and a parentheses, but a lot of people, if you have multiple parentheses in the same equation, they'll use brackets, so it's a little bit easier to tell them apart. Then I need to distribute this negative. Negative 6y plus 15 minus 5y plus 5 plus 3y minus 3. And then I'll gather up all the y's. Negative 6 and negative 5 makes negative 11. Plus 3 is negative 8. Negative 8y. And then 15 and 5 is 20 minus 3 is 17. Plus 17. This becomes 29 minus 2y. Which way should I move the y's? Add the 8. Does it really matter? No, but we do like to keep our largest our leading coefficient positive. So 6y subtract 29. So that would be, what is that? Negative 12. Divide by 6 and I get y equals negative 2. Does that make sense? We're good there? Okay. Look down here. So the instructions say clear the fractions by first multiplying by the least common denominator and then solve the resulting linear equation. So if we look at number 28, it looks super messy. 1/12 z equals 1/24 z plus 3. But equations are simply a balanced teeter-totter. There's just as much weight on one side as there is on the other side. And we're allowed to do anything we want to that teeter-totter as long as we do the same thing on both sides. If I put 6 pounds on the left side, then I'm out of balance, but if I put 6 pounds on the right side, now I'm back in balance. If I remove half of the weight on the left side, now the right side would be too heavy. And if I remove half of the weight on the right side, then I'm back in balance. So what can I do to number 28 to remove the fractions and keep everything balanced? Well, I can multiply everything by the least common denominator. Okay? If I were to times this, say, by 4, would that make it easier? Well, what is 1/12 of 4? What's 4 times 1/12? It would be 1/3. So I would get 1/3 z. And what is 4 split into 24 pieces? Oh, that should be an equal, sorry. So that would be 1/6 z plus 3. Is that a better equation? Yeah, a little bit better. It's better than the original, but it still has fractions in it. So what if I multiplied by, let's say, 144? If I did that, I would get 12z equals 6z plus, what is that? Anybody got a calculator handy? 144 times 3? 432. Is that a better equation? Yeah. Could we do something that was less complicated? We could. So what we do is we look at all of the denominators. What is the smallest number that all three denominators go into? The least common multiple. And the answer is 24. So I multiply by 24. And I get 2z equals z plus 72. Thank you. Is that an easier equation? Yes. Have I broken the teeter-totter? No. Whatever was over here on the left side, I multiplied it by 24, which made that left side way heavy. But the stuff on the right side also got multiplied by 24, so now I'm back in balance. Okay? I'm not even sure what's over here on the right and what's over here on the left. But whatever was there, I made 24 copies of it. And that eliminated all the fractions. And then I can just subtract z, and I get z equals 72. Does that make sense? Okay, look at 34. What am I going to multiply by to clear out that fraction? 72. How do I know 72 works? Because 8 goes into 72, 72 goes into 72, and 3 goes into 72. Now, if you don't know, you can always just multiply these together, and you're going to get some big nasty number, and you can use that number, but your coefficients will just be a little bit bigger. It will always work, but it's just a little bit more effort. Okay, on number 37, what are you going to multiply by? 6. Okay, piece of cake. Get to work. Oh, I got to get back to here.